anyways, this is not analysis results because we want to do a nonlinear analysis in which the cables act as tension only members. Okay, so let's go and try to do that. If we go to file, exit now, here what we could do is we can go to modeling, and there's an option called nonlinear effect, and you can say tension only members. Okay, and then you can pick the cables that you want to have function as tension only members. Click on OK, and what that does is it puts in a command called tension only members existing 103 to 107. Okay, so those are the member numbers. Now, to analyze this structure, first what you need to do is analyze it using nonlinear analysis feature, which is tension only members. Now we've already done that. Okay, so we can also go in nonlinear analysis, and here pick the nonlinear analysis parameters and solutions. So we're going to use 25 iterations, execute this analysis, click on OK, and what it does is it runs a nonlinear analysis this time. Let's go to modeling and GT menu. So this time it'll show you the results. If you go to deform shapes, here you could see, you know, it doesn't make a whole lot of difference, but this time it'll ensure that all these cables are in tension and not taking any compressive loads. Okay, so if you wanted to see the loads in these cables, what you could do is first know what these cable member numbers are. Okay, so you can go type in LM label member, so you can see it's 103 to 107, right? So if I go to results, data sheets, member end forces, okay, it'll show you the member end forces for the entire system, but I can go in and filter these settings and just say I want to show every you know, the results for member number 103 to 107. Okay, and click on OK, and it'll filter that, but I think I just said load IDs. Didn't want to say load IDs, I want to say member IDs. Sorry about that. So if you go 103 to 107, click on OK, you see the tension in these cables. Now you want to compare that with the allowable cable strength. Okay, so you would multiply this by the factor of safety and compare it with the allowable. So it better be lower than what we have. So we have about 20 kilonewtons, okay, of force in these. Now you can go in and write these to a file, okay, on your desktop. Let's say, okay, I'm just going to place it under C:, data, skid, and here I'm going to say cable forces. And what it does is it creates an Excel spreadsheet of the same output that you see. Okay, so I can go to browse and go to C:, data, and skid. Here are my cable forces, and you can see that in the graphic. So you can go in and format it and so on like you want. Okay, so once you've done that, you know, you can copy this to Microsoft Word if you wish, to highlight all the cable forces that we have. Okay, now let's close that. So we know the cable forces. Now what we need to do is design the skid, make sure that the design of the skid works. Okay, so before we do that, I'm going to make this problem a bit more interesting. What I'm going to do is assign some loadings, and in this case I'm just going to change the units to, let's say, kilograms. Okay, and then I'm going to add a add some loadings. Okay, so for example, let's say there's equipment attached to the structure. How do I account for it? Okay, so what I can do is I can go to edit, then go to loads and edit, I can add a new load. Okay, let's just add equipment load. Okay, so to equipment loading, and here I'm just going to add a joint load, and I'm just going to say add a joint load. Okay, so let's say there's some equipment located here, at these points. Okay, and I know what that loading is supposed to be in kilogram. Okay, so in the y direction, let's say apply a negative 20 kilogram of loading, and you can see that loading being applied in the graphics. Okay, now let's say you want to add another load, call it floor load. Okay, you can add that floor load, and you can say it's a member load. And you can add it inside inside the graphics. Okay, you can or what you could do is you can use the area load generator. Okay, let me show you an example of that. So I'm just going to save this file. I'm just going to say generate gtstrudel file. I'm just going to save this file as the same name, and then go to file, exit GT menu. Now here inside the GT shell, there's an option called modeling loads and area loads. Okay, so here you can say new area load. I'm just going to call it load case number 4, and this is going to be an area load, let's say. And then if you know what that area load is going to be in the y direction, let's say, I can just say in the y direction, click on OK, set elevation to, let's say, this joint. Okay, I want the whole skid to be loaded. And for the loading, I'm just going to say it's about negative 47.1 kilograms per square meter. Okay, click on OK. What it'll do is it'll do a two-way distribution of that load, show you a load distribution diagram. You can label all the members, and once you're done with that, you can just click on done. What that does is it creates an area load for you, area load command. Now what I usually do is these I can create a seed file of all this information. Okay, so for example, what do I mean by that is it's like a template that you can create. In my C drive, I have a skid1.gti file. I can just say paste, and I can call this file as a template. Okay. Now in this template dot let's say rename it as a text file, because there's only text in it. Okay. What I can do is I can just say, I can remove all the member definitions, the node definitions, and so on in it. But what I can do is I can just maintain a few types of loadings. Let's say for example, let's say just a self-weight loading. We can put in an equipment loading, and then we can put in an area load. Okay, so I'm just going to say area load. These commands could basically be whatever is shown in GT shell. Okay, so I'm just doing it, copying those commands, so you don't have to go through the process of specifying that through the menu all the time. Okay, now these templates can also contain things like design parameters and so on. Okay, now for the design, let's say let's first run the analysis. Okay, if we go to analyze, we can do a nonlinear analysis solution, and what I can do is execute this analysis, click on OK, and we have a instability. Okay, so what that means is these solution didn't converge, and we have a problem. Okay, and the problem occurred for load case number 2, and it may be because the cables are probably going into compression and so on because of the weight that we had assigned. Okay, so no problem. Now what we could do is we could go to the modeling and fix the file. Okay, now we have the text input of this file already created. We can go to file, generate the text input, but what it'll do is it'll recreate all the area loads. Okay, so in this case, if we go to area load, we display that we have the area loads applied in the wrong direction. Okay, so that's a mistake. Okay, so we can go in and delete that area load, but rather than do that, what I'm going to show you is let's just abandon this model. Okay, now the area load, the problem is we shouldn't have given this negative sign, so I'm just going to get rid of that negative sign. Okay, next thing, for the equipment loads, I'm just going to include that it's going in the global Y direction, so that's fine. So what we could do is create a load combination of that and run it. Okay, now in the skid.gti file here we do have the loadings defined. Okay, so I'm just going to get rid of all these loadings that we have. Okay, so that when we open up this file, there's only the geometry that comes up, right? So if we go to GTStrudel 2018 and open up the command mode, open up this file that we have created, it has just the geometry, right? Now to create the loadings, easy. We just copy these commands, Control C, Control V, and it does the area loading for me. If I go into modeling graphical user interface, this time you should see that the area load is applied in the correct direction, right? It's going down. So that's what I mean by creating templates. You can create those templates and actually store them inside Strudel if you want. Okay, now what you want inside the template is also things like things that are like you can put in comments. Okay, comments actually start off with a number sign. Okay, so you can just say a dollar sign, and you can say, okay, this is a template to design simple skids. Okay, with a full stop, and then you can put in a bunch of dollars just to make sure that these are commands. Sorry, these are comments. Okay, and I'm going to save that. Okay, now you can also put in load combinations and so on. Okay, now let me show you how to create a load combination. So this is GTStrudel 2018. I'm going to open up skid1.gti, create these, copy and paste these commands. Now to create load combinations, you can go to modeling,